It's opening downwards. The opening is towards the negative side of the y-axis. The vertex. We can locate the vertex. It's located here. The coordinate for this vertex is 0, which is our x value. It's on the y-axis, and it's at positive 7 on the y-axis. The maximum value. The maximum value is equal to the y-coordinate of our vertex. The y-coordinate is 7. So our maximum value is y equals 7. The graph of a linear relationship always has at least one and up to two intercepts. If the equation is in the form y equals mx plus b, where m does not equal 0, the graph will have two intercepts. Here's an example of a linear equation or linear relationship in the form y equals mx plus b. Here is the y-intercept. It's where the line crosses the y-axis. Here is the other second intercept. It is an x-intercept, where the line crosses the x-axis. If the line is vertical or horizontal, then the graph will have only one intercept. Here is a horizontal line. This only has one intercept. It's at the y-axis. It does not meet the x-axis. If there's a vertical line, such as this one, it will also only have one intercept, and it will occur as an x-intercept, because it will not ever meet the y-axis. Parabola, the intercepts. The graph of a quadratic relationship always has at least one, but up to three intercepts. If the parabola is facing upward and the vertex is above the y-axis, then it does not have x-intercepts. Here's an example of that. Notice that the parabola does not reach the x-axis. Therefore, it will not have an x-intercept. It does, however, have a y-intercept, located here. So in this case, this parabola will only have one intercept, and it is a y-intercept. The same is true if the parabola is facing downward and the vertex is below the x-axis. So if it's below the x-axis and it's facing downward, it will never intercept the x-axis. It will, however, have a y-intercept, although we can't see it on this graph. This line will continue this way and eventually cross the y-axis. If the parabola is facing upward and the vertex is below the x-axis, then it also has two x-intercepts. Let's have a look at an example. So, if we were to move this parabola, below the x-axis, we can see that there'll be two intercepts, two x-intercepts. The same is true if the parabola is facing downward and the vertex is above the x-axis. Like our previous example, if we were to move it upwards, we would see two x-intercepts. Let's look at zeros for a parabola. The graph of a quadratic relationship always has one y-intercept. The graph of a quadratic relationship can have 0, 1, or 2 x-intercepts. The x-intercepts are often called zeros. We call them zeros because where the line crosses the x-axis, y is equal to 0. Looking at this example, we see one y-intercept. The y-intercept is at 0, 1, where x is 0 and y is 1. This point is our x-intercept, or our 0. It's located where x is equal to 3 and y is 0. For this example, the x and y intercepts are equal because the graph goes through, or the parabola goes through the origin at 0, 0. So the y-intercept and the x-intercept are the same. If the vertex is on the x-axis, the quadratic relation will have only one 0. So if we were to move this example anywhere along the x-axis, the quadratic relation will only have one 0, or one x-intercept. If the vertex is not on the x-axis, the quadratic relation will have none or two zeros. Here's an example. This quadratic relation does not cross the x-axis, so it has no zeros or no x-intercepts. Here's another example where it does not have a 0 value or an x-intercept. Here's an example where there are two x-intercepts or two zeros. Another example. Here there are two zeros or two x-intercepts. Let's look at this example and determine by looking at the graph the y-intercept and the zeros of a given quadratic relationship.